Many of you have been asking for a Topaz test on the current generation M2 machines, so here it is. Let's find out how these machines perform with Topaz on the different apps. This is ArtIsRight. Before we start, subscribe if you're new and hit on the bell icon so you'll be notified every time I upload cool new videos like this. A big thanks to those of you who have already subscribed. If you're new, please consider subscribing so that we can reach a larger audience, and hit on that like button as well. All the videos on this channel are pretty much self-funded, especially when it comes to these comparison videos. If you find the information I'm sharing with you helpful, please consider supporting the channel. I'll leave a link to my tip jar in the description, or you can choose to use YouTube Super Thanks as well. All the contribution would go into directly running this channel and for future hardware purchases. This said, I'll be sharing with you a lot of information, so I highly encourage you to pause the video so you can analyze the result yourself in addition to the analysis I'll be sharing with you, and as usual, there'll be timestamp in the description. For this, I'll be testing various M2 machines with various Topaz software, Denoise, Sharpen AI, Giga AI. All these have AI in them, video AI. However, I am not testing this on the photo AI because I really just want to break this down and run them by the individual apps and see how they perform. And with this said, let's take a look at our test system. You're going to see results from a few Mac Studios with the M2 Ultra, so two of them are going to be there. This is a stock configuration with 64 gigabytes of memory. I also have another machine that's been upgraded to 128 gigabytes of memory, and we are also going to see a stock M2 Ultra Mac Pro as well. So we're going to see how they perform against each other. And then also you're going to see results from an M1 machine with 16 gigabytes of memory, M2 that's been upgraded to 32. This is pretty much just the base SoC on this one. M2 Max, again, base SoC and 32 gigabytes of memory. This is a stock machine. This one has the upgraded memory. And lastly, we're going to see a result from two MacBook Air. One of them is going to be a 13-inch, the other one will be the 15-inch one, and the memory on these two machines have been upgraded to 24 gigabytes. Now, there's something to note as well about the neural processing engine between these machines. For example, on the Ultra, there are 32 cores, neural processing engine, that is the machine learning cores, whereas on these other machines, from the M2, M2 Pro, and M2 Max, you're looking at around 16 cores, neural processing engine. So we're going to see if that contributes to any variation as well. Now let's take a look at our test images. For this, I'm going to use the Aurora image. This is a Nikon D810 file, and I'll be testing two variety, a JPEG and also a raw NEF. The JPEG is around 50 megabytes, the raw NEF is around 46 megabytes. And the next one that I'll be testing is a really large file. This is a panorama merged from multiple Nikon D810 file. The pixel dimension itself is around 21,000 by 7,000 pixel. This essentially can really print out around 44-inch by 7 feet or so. It is pretty crazy. The JPEG file, this is around 128 megabytes. The DNG is 689 or 687 megabytes or so, rounding up. So it is quite a large file, and we're going to see how they run. A few things to note about the settings with all these programs is that I have gone into the preferences for the program, target the SoC I'm using, and allowed memory consumption to go to pretty much high. As far as just testing this goes, I mean, if you don't go in and choose the AI processor, it's still mostly default to the neural processing engine on the Mac anyway, and doesn't really use a GPU. You can kind of force that even with like when you have this option, but for the most part, I found that it just automatically goes in and chooses a neural processing engine anyway. But what I want to do is just to ensure this, so I went and select all these options. Same thing with the video AI. I mean, there's really no place where you would choose the neural processing engine or not, but for this, you have the option to choose the max number of processes that you wanted to put through. And the max for all these, even on a high core count machine like the Ultra, M1 and M2, 20 core and 24 core CPU, we're still looking at, 4 processes at the very maximum. And I dialed the memory up to 100%, although I was really not using that much to start out with. So some of the observation I have about this is what you're seeing right now is iStat Menu 6 screen capture of the various performance on my M1 Ultra while all these Topaz programs are running. So with this in mind, we can see that the CPU is barely being utilized. And one thing that I'll probably tell you right now is if you're really configuring, for example, an M1 or M2 Ultra to run Topaz, that's probably not going to be the best combination, but we're going to take a look at the results in a bit too. But you can see clearly that many of these CPU cores are just pretty much left empty. If not, they only peak a little bit, while only a few of them are being really fully saturated. I mean, it's not really going in to utilize the resources that are available on the system. Here it is, the CPU chart, and what we can see right there, this is pretty much Video AI, and the rest are pretty much Sharpen, Denoise, and also Giga AI. Video is using quite a bit of the GPU, but when it comes to the rest, we do see some peak here and there, and maybe just like, you know, a little bit more sustained peak in some of the programs, but it's not constantly going in to utilize these resources on the system. The other thing that I notice about all these programs as well when it comes to Topaz is that it runs in a very serial manner, meaning that it just works on one task at any given time without trying to go through and process multiple parallel tasks. I'm not sure if this has to do with a limitation, the way how the program is coded itself, or just with the neural processing engine, the way how the machines are running, but it is one of those things that can quickly be a bottleneck, especially if you're processing hundreds of files through these programs. Don't get me wrong, the algorithm that they're using are really good, and they are using an AI or machine learning model that is being applied to the picture and being run through the neural processing engine. So I was able to like verify this information, which is a great thing to see. But overall, I still think that there are ways to optimize the app itself to make it, I would say, more parallel in the way how it processes the image. And that would have just been a really fantastic move for these. Now, here's some information on reading a spec. I'll leave a link to this in the description too, so if you want to come back to this, you can. Here's the abbreviation chart for the specs, and we are going to start out first with Sharpen AI. So with this, we're going to look at the Aurora, and here is the timing for the RAW, NEF, and JPEG. What we can see for the RAW is that pretty much the M2 generations are sitting at the very top beside the 2 Pro right there. That's coming just about a second behind. But if you're really looking at these machines right now, they're really just about a second apart from each other, with the only 2 machines that are taking longer being, for example, the Mac Mini M1 and the 13-inch MacBook Air. The 15-inch MacBook Air is performing really well, and interestingly enough, I've tried to like run multiple different tests on this. The 13-inch MacBook Air, it tends to be a touch slower, but one thing that I also found in my testing of the MacBook Air, as well as on my machine, the SSD speed is a little bit slower on the right part of things. I'll leave a link to that video that I did a comparison between the 13 and 15-inch MacBook Air M2 in the description as well, so you can check that out. All right. Other than that, when it comes to JPEG, the timing are a little bit longer on some of the machines, but the results is pretty much following the trend of what we're really seeing in the RAW file. Most of these, I would say, are just as expected, with the M1 Ultra slotting in right there at around 10 seconds. So the M1 Ultra is not really performing too well at all when it comes to these tasks. And interestingly enough, if you upgrade your M2 Ultra to 128 gigs, you are getting a slightly better performance, only a few seconds. But when you really start to compound this with 100 files, it may make a difference in your workflow. This would really all depends. Now let's take a look at the panorama in Sharpen AI, DNG and JPEG at the bottom. So on the DNG, these are pretty much the timing cascade of each other. We're still looking at a few seconds apart. It's really not that big of a deal at all. I mean, considering that there are much more resources on these Ultra machines, we would see, you know, timing get cut in half, but that's not the case. And also having more RAM on the system doesn't really attribute to a faster time either. What about GPU? We take a look at this. We're looking at 10 GPUs so far on these machines. 1630, we're going up on the GPU, and this is really starting to give you a picture as far as the performance of these machines. The more GPU you have on here, the better it starts to run. And also, not only just that these Ultra has more GPU on the chip itself, but it also have more neural processing engine as well. One thing that I don't have is the top-end M2 Ultra with the extra GPU cores, but based on the data we're seeing right now, you're really only going to save maybe a few more seconds, and you're going to pay $1,000 more. I don't really think that's worth it. So when it comes to Sharpen on the JPEG itself, some results are somewhat mixed. I mean, there's machines that are slightly faster, so the arrangement will be different, but all the arrangement are based on the RAW, and the results are as what we would expected, almost in line with what we get with the RAW file. Now let's take a look at Denoise, the result for the Aurora Borealis, which is captured at 6400 ISO. For this, we're seeing the timing spread that are only just, I would say, a few seconds apart. It's really not that big of a deal at all, and very similarly, you're only seeing a few seconds apart on the JPEG as well. What's interesting about all this is that even though these may only show a few seconds apart, they do represent a huge jump in the amount you're going to pay for the machine. So for instance, going from a 64 M2 Ultra in the Mac Studio to a 128, you're looking at around $800 price variation right there being added onto it. The M1 Ultra is still a good performing machine, as you're seeing right there. And I would still say that the M2 Max, even compared to, for example, the M2 Ultra right here, this is pretty much just the base SoC, is performing just about the same. And there is a difference of about $1,000 between them. So you're really looking at a lot of price variation, or a huge gap in price variation, for a very small performance gain. So really think about your workflow. As I will share in other videos and these comparisons, think about the other programs you use. For example, if you use Lightroom, configure for those major apps instead of these ones, because these ones are not really going to give you the performance bump, yet you're going to be spending a lot more money anyway. So I would say save the money if you can't utilize the resources. Now let's take a look at the Denoise AI on this panorama image. So with this, timing are still only a few seconds apart with the Mac Mini, the MacBook Air. Those are just the regular M1 and M2 SoC running just slower than these other machines. But when it comes to these pro machines, they're running just about at the same rate. You may get 5 seconds faster with the Mac Studio versus the M2 Pro on the DNG for this file, the RAW. When it comes to the M2 Ultra 128, we're not really getting that better performance. In fact, it is a bit like 2 seconds slower. So these are some of the things to really think about when you're really looking through this. Now, are these good performing machines? Yes, but like I said before, you really need to think about the tasks that you're really using these to do. Now let's take a look at Giga AI. So for this timing cascade, only a few seconds apart. One benefit that you get from upgrading to more RAM on the system with Giga AI is that the 128, when it comes to a raw file, is running that much faster than the rest of the machine. In fact, it's about a third faster compared to the rest, which are just only a few seconds apart. They're not that big of a deal. The M1 is the slowest machine. It's no longer really holding itself just fine with all these modern tasks being thrown at it. And interestingly enough, these are the two Airs. You can see the result there, the 13 and 15 inch performing just about the same. And here are the spreads for the JPEG. So like I said, feel free to pause this. You can analyze this yourself too. Here's the Denoise AI on the panorama, and this almost showed no time differences whatsoever between the 128 and the 64GB machine. I mean, it doesn't really make sense to get the M2 Ultra, or even that matter, to get the M1 Ultra to run any of these Topaz software. If these are the primary app that you're using, I would probably look at the M2 Pro or M2 Max. Just look at the Max or the Pro SoC. I think these are going to be the best thing that you can do. There is some slight time variation between these, but again, you can see that they're really just only about a few seconds apart, and at the very most, we're not even stretching a minute between all these machines in the M2 generation and also the M1 Ultra. The only machine that took a little bit longer is just the M1, but that just makes sense. And now let's take a look at Video AI. It is still not going to utilize the system resources fully, and based on the numbers I'm seeing from these, I don't genuinely believe that the program is really utilizing the encoder-decoder engine inside these SoC at all, which is really kind of sad actually. You really think that these apps would really go in and utilize a neural processing engine at the same time. However, it's really not doing that. It's just simply using a lot of GPU to stitch all these together. It's not even going to utilize that much of the CPU. Kind of not really a good resource utilization software. But anyway, what I have is a short video clip that I've put together. This is back in my student days when we were still filming in 480p, and I'm upgrading this to 720p, and these are the result that you're getting right now. Timing, they're only, I would say every one of them are about 30 seconds apart, and they do start to add time a little bit, but it's really not that bad at all. The slowest on this is the M1 Mac Mini, but remember that you can get this machine for, I would probably say, sub $1,000 easily, maybe about $700 or $800 for this configuration itself. This one, the 128 M2 Ultra, is close to $5,000. So you're taking a look at a machine that costs more than 5 times the lowest one. And yes, it can export at around 50% faster. But if you take a look at other machines in the lineup, the variation is really not that big at all. For example, going from the Mac Studio with 28 to 64, we are talking about a price delta of $800. And if we start to go down, for example, the M2 Max compared to the M2 Ultra, we are looking at $2,000 price variation. So if you're going from the Max to the Ultra, you're paying $2,000 more. If you're going from the Ultra to the M2 Max, you're paying $2,000 less, and this is less than a minute apart for these processing times. You start to get the idea as we go down the list. We start to see machines that goes lower in pricing, and at some point though, we are going to reach that breaking point. And I would say that the breaking point is somewhere around here with the Mac Mini M2 Pro, because the pricing for the M2 Pro and the M2 Max are really close to each other, especially when you really go in and configure all the other aspect of the machine. That I would say that if you're going to really upgrade the M2 Pro Mac Mini anyway, just go for the M2 Max. That's going to be a much better value. But when we look at the M1 Ultra, it's performing just a bit slower than the M2 Pro. Now, should you go in and get the M1 Ultra? Well, it all depends. If this is the only thing you do with video, then no. But if you are using other video editing apps that can really go in and utilize the encoder decoder engine on the SoC, I would say, yeah, M1 Ultra is still a really good deal to consider. So here's a conclusion based on the result that we can see. Topaz does make decent programs, however, they're not optimized. Where they really shine are the different AI models they have come up with and running those AI models on the neural processing engine on the SoC. Where they don't really shine has to do with optimization, because probably about 2 years ago when I tested their app, their performance is still just about the same. We still don't get parallel processing. They're just still going about every single image in a very serial way, one image at a time, not the best utilization of system resources. So what it really comes down to is you really have to ask yourself, are you using Topaz as the primary program where this is all that you really spend time doing something? If that's the answer, then definitely look at these charts to try and configure the best machine for you. My recommendation, look at either the M2 Pro or the M2 Max, or just either the Max or the Pro. Even in the M1 are going to do just fine. And I know I have not included those results from the machines here. But if you are using these Topaz apps as an ancillary program to your primary app that you're using, for example, Lightroom, Lightroom Classic, Photoshop, Capture One, Final Cut Pro, DaVinci Resolve, Premiere, or even After Effects, then I will look at the way how those apps are running on the system and configure your computer based on the primary task that you're doing, and don't worry about the results of here much. Because you already saw that when we take a look at the timing for all these, the variation on some of the tasks, only a few seconds. At very most, we're seeing 30 seconds or maybe just a minute apart from each other. They're not really that big of a differentiator, yet the price, when you really start to go from the bottom end to the top end, we're looking at something that can cost 5 to maybe even like 10 times more depending on the machine that you get. So it really just all depends. And I'm hoping that you find this information helpful with all these Topaz tests. If you have any questions or comment, leave them below, give this a like, subscribe, and hit on the bell if you're new, and in art we trust.